So we talk about fourth industrial revolution, but yet there isn't really quite a definition for what it is. At the same time, while it's clearly technology is going to be a lever, there are so many problems that manufacturers face day to day, whether it's the labor shortage, whether it's supply chain volatility, and the bullwhip effect when it comes to managing a supply chain. And at the same time, you see so many different parts of manufacturing technology emerge. So you've got every acronym possible, from PLCs to MES systems, SCADA systems, and while it's been great to give a lot of things definition, it's created a lot of silos when it comes to running an actual shop floor. And if you go into any kind of manufacturing business, you're going to see everything from paper, whiteboards, Excel, and all these other systems. So how did we get here? So this is a quick arc of the story of how we came to the fourth industrial revolution, what it even is. So it started with one-way telemetry, evolved into two-way for power and transportation. Next, you had your first mini computers. The first computers were used for manufacturing itself. And this evolved into the birth of SCADA and PLCs for controlling processes. And this was the third industrial revolution. And ultimately, as the systems evolved, we're here. And we're looking forward at what is this next crank of efficiency, the next crank of technology. And we all know it involves some kind of leveling up with robotics, with more data. But what does it really mean? And this is the crazy tech stack of manufacturing technology. You've got at the very top ERPs, then you've got a layer below that, you've got MES systems, then you've got SCADA, you've got HMIs. And as you can see, these have really defined the way manufacturing technology works. It's largely architecture driven than the way folks want to use technology and adopt it. And this is inherently what's created a lot of the silos. So the limitation of these models have been, it requires a ton of IT support. If you're working with 10 different moving pieces of technology, you need a lot of on-site IT capabilities. This works great when you're a centralized oil and gas manufacturing business, but when you are doing machining with 50 employees, it can be really hard. Normalizing this data from all these different sources, when you've got wide dimensions of data from different sensors, from different systems, how do you really make sense of this in one place? And then finally, it's disconnected from the business system. So as we saw in the graph, you have your ERPs at the very top, but then the MES system is really without a lot of the main business context. And this is where the model is changing. There's a large appetite for integrating systems, removing these silos. The second is the labor shortage means every person in the manufacturing business needs to be empowered more to win the day and have the resources they need to execute the tasks. The cost of capital is growing, whether it's in competitiveness, whether it's in interest rates, or any other macro factor. And just like any other vertical outside of manufacturing, you've moved to an architecture where you're looking for the best-in-class systems for each use case and combining these into a single, broader system. And finally is the world of spending 6-7 figures to get started on an IT project has just become untenable. And so moving to a more agile and system that has optionality for consumers. So these have been the driving forces. And I find machine monitoring to be an interesting intermediate step. So candidly, Ampere was started with the idea of making it easy to connect machines and simplify the problem of machine monitoring. And over the years, as we've started to show this data, we've come to learn machines are one element out of many elements on the shop floor. So you can accidentally, while trying to invest in technology, manufacture new silos. So you can improve your machine uptime on jobs that aren't right for you. You can potentially increase your scrap rates if you're not looking at a holistic picture of your business. You can take on less complex jobs that are less profitable in order to have higher machine uptime. And if you don't really look at the labor cost aspect, you might still have the same direct costs. And so you're not really seeing any of the bottom line impact by investing in technology. And so that's where Ampere comes in, which is we're looking to break down silos across all these systems. And this really comes from orchestrating and connecting the key elements of your business, whether it's machines, people, and your processes. And I'm going to go over a couple of examples of what this looks like when it comes to unlocking this potential. So we're going to go over 5 different concepts, which is number 1, control the day. Second, focus your improvement efforts. Third, build a high-performance culture. Drive margin expansion. And finally, connect all your systems. So the first is control your day. Now, as you walk around, again, there's so many great technologies over here, but having a dashboard with machine data is not a new idea. But I think it's so important to go beyond just looking at if a machine is running or not, or what is the OEE. So over here, you've got an evolution of the system where it actually combines a work order. It looks at who's running the machine, what is the estimated ship date, how far along are you, and crucially, through intelligence, what is your estimated ship date and what is the forecast based on technology. And so the big difference over here is it's not just showing you machine monitoring data, it's actually combining a lot of different elements to help you orchestrate your business. So it combines your sales, your people, your live data, and it actually uses intelligence to predict where you're going to end up. Second is focus your improvement efforts. Again, a Pareto of downtime is a great first step in understanding where your losses are, but how do you take it a step further? Over here, you can see by combining systems, you can actually attach dollars to every loss that you have in your business. And so this means combining your labor rates to your job rates to your different machine rates. And so over here, you can see on the slide that you've got the actual losses by fault code, by reason code, by scrap code, and so on, as well as looking at by machine, what is the cost of capacity, whether it's in revenue or in the bottom line. So this is just another example where simply collecting machine data would mean just showing a Pareto way on losing time. Over here, it's combining all the different business context elements to show a holistic picture of where the losses are. The next is building a high-performance culture, both on the shop floor and off the shop floor. So on the shop floor, this is what it might look like, where you can start to see by combining labor records and transactions of when people are logging in, logging out, you can actually get a complete picture of how effective folks are. In the world of turning and machining, you can often have an operator looking over multiple machines. And again, when it comes to machine monitoring in a silo, it doesn't quite answer which operator is the most effective in setting up multiple jobs, running many machines, having the lowest scrap rate, and so on. And again, this is breaking that silo of being completely machine-centric. You can also start to see which machines have enable operators to perform better. So on the top right, you can see by machine where are operators more successful than others. And as I mentioned, building a high-performance culture both on the shop floor and off the shop floor. When it comes to breaking down silos, often machine monitoring has this notion of tracking the shop floor, tracking people, and at Avro, we've been able to flip the script where we actually help operators get help. So there's an and-on system where they can call for help, sends a real-time message, but crucially, it actually shows the response time of support resources like quality, programming, maintenance, to actually get to the operator and help them, run the day-to-day. And finally, we have driving margin expansions through job analytics. So again, combining these different pieces of context, you can get a complete picture on which steps in your routings are off, where are you misquoting versus what's actually happening on the shop floor, as well as understanding things like OEE, by part number, by job, and so on. And so I think just to take a step back, all these examples stem from real data from the shop floor that's automatically collected, but combining this with a lot of context around the business, around people, around jobs, around sales, you really get a complete picture that allows you to get to answers, as opposed to just some information that you now need to process with a lot of heuristic context. So I'm going to go over 2 quick examples of what this looks like in the real world. So Bellevue Universal, they are a precision machining manufacturer that makes universal joints and shafts. They're based in Chicago, and they started the journey with simply creating a baseline around the utilization. So these are $500,000 CNC machines, and to know if it was running or not, someone had to walk out, manually, physically check what's going on. That is the start of the journey. And I think the curiosity bred a lot of questions around, well, should I be buying a new machine? Should I be adding another shift? Should I be compensating a certain operator more than others? And so it's been a journey for them to combine all these different elements and bring in the people in the job context so they can get to answers around, is this a profitable job or not based on what data is telling me? Is this someone who deserves a promotion? Do I have a certain role that is unfilled on my shop floor based on the data? So again, it's starting your journey with the step of what's really happening on my shop floor, but ultimately, our view at Amper is it's a very narrow view. If you're simply looking at machine data, you've got to expand the aperture over time. Another great example is with another customer of ours, AD Hawk. And like any other manufacturer, they had labor shortages and wanted a tool to attract and motivate their workforce. And using machine data, they were able to identify signal and a leading indicator that really signaled when someone is being productive or not. And they've started having compensation plans that are based on what is the total paid labor utilization, meaning for a given number of hours that folks are paid out for, how many actual parts and production hours are you able to get out? So again, this is combining a very visceral element of payroll and compensation plans with machine data to give it a complete picture. I just want to give a bit of context on Amper. So as I mentioned, started this company with the goal of democratizing these systems for small, mid-sized manufacturers. And our goal is to help folks embrace reality with real-time data, get to answers, not just information that'll ultimately help drive on-time delivery and expand margins. And finally, empowering the folks that are actually running machines and running operations day-to-day to unlock the potential. And really excited to share this. We have the Amper way, which is a very prescriptive way of how you can adopt these technologies. And it starts with creating a baseline and then growing into these additional systems over time. The reason this matters is because it's nearly impossible to get to this end state of every element of your business, from your sales to your jobs and your operators being all connected to the platform day one. And setting that as a goal is, again, essentially deferring these initiatives. And so it's so important to start simple, crawl, walk, run, and grow into these larger pieces of context. And so, obviously very exciting to be here at PMTS. There's a ton of cutting edge technologies. And as folks look around for what systems make sense for the shop floor, here's some heuristics or piece of advice that we have, which is you want a system that's agnostic to your environment, whether it's your machines or your systems. This is going to be crucial because you don't want to, again, manufacture a new bottleneck by only having a partial view of your business. The second is expertise. Manufacturing is just such a technical and detailed industry. You want folks that are able to hold your hand through this journey because, again, it's not an overnight plug and play. It's a journey with lean. It's a journey with culture change and so on. The third is, having grown up in manufacturing, seen my family's business buy a lot of technology over the years, transparent pricing, adoption plans, and the ability to do a trial, again, is so key in really seeing this in a tangible way to validate what it takes to get a system up and running, to people like it, and so on. And finally is more than machine monitoring. Again, while it's a great starting point, the end state is to combine the key elements of your business that really matter. So there's lots of technologies out here. I hope this gave a new lens to the world of machine monitoring and where the future might be. And I'd be happy to take questions. And for what it's worth, we have a booth right here. So happy to give a live demo and chat after this talk as well. Thank you.